Hello students, Ms. DeLeo here to walk you through section 4.5 notes. We're going a little bit into more on scatter plots and even further on describing correlation. So the last time that we did a lesson together, you guys were making scatter plots with lines of best fit. And we were kind of talking about how everyone may have a different line of best fit based upon the points they choose, and that was okay for us. And for the entry level of this lesson, that is true, that is okay. But it should be known that in statistics, in scatter plots, there is only truly one and only one true line of best fit, and it is the best fit for that data. And it's really hard to calculate by hand to know exactly which points to choose that give you that line of best fit. So we can use a calculator to calculate that exact one and only line of best fit using a method called linear regression. So we are totally fine at this time and this level with just eyeballing it, trying to get about half the points above the line, half the points below the line, and as many points on the line as we can, even better. And later on and now we can kind of look into linear regression at what that exact line of best fit is. In order for us to kind of assess how good the linear strength is for a line, we use a measure called the correlation coefficient. And we use the letter R to represent that number. And this helps us determine how appropriate a line is, how appropriately a line fits a particular data set. So yesterday's notes, we kind of learned that you can talk about correlation as positive or negative or none, but now we can even go a little bit further and describe the data even further based off of this R value that we're talking about, this correlation coefficient. This tells us if our data is not only positive, negative, zero, or none, no correlation, but it tells us if it's a strong linear correlation or a weak linear correlation. R has the following properties. If you have an R value of 0, that means we have no correlation. And remember, that means that your scatter plot is either completely random or we have a scatter plot that has a non-linear pattern. So there could be a relationship, it's just not a linear one. So if we see a correlation coefficient of 0, we know we have one of these cases. Okay. Now, a correlation coefficient can range anywhere from -1 to +1. And within these bounds, we've got some notable values that kind of give us insight as to how strong the linear fit is. So if we have a value between 0 and 0.5 on either side, this is considered a weak linear fit. So we can have a weak negative fit or a weak positive linear fit. And this value just kind of helps us put, even more descriptors to what we know to be true. If we have an R value between 0.5 and 0.8 on either side, we consider the linear fit to be moderate. So the linear fit might be appropriate, but it's not super strong. All the points are not exactly on the line. A line does estimate the trend, but loosely. And if we have anywhere between 1 and 0.8 on either side, as far as our R value goes, this is an indicator of a strong linear fit. So yesterday, when we were looking at your examples, some people said, you know, even though that does look positive, it doesn't look very linear. So then we might have something like this. We have a positive association, but it's weak. Or we can have a negative association and it's weak. A moderate positive, a moderate negative, a strong positive, a strong negative. Remember, positive meaning our data is increasing in a linear pattern from left to right, and negative meaning our pattern is decreasing in a linear pattern from left to right. So now I can kind of look below at these graphs and answer some of these questions. It says, determine whether the correlation coefficient is positive, negative, or 0. Take a second to pause this video and complete these 4 examples. Okay, now check. Did you get them right? So we're looking at whether we think our correlation coefficient or our R value would be positive, negative, or 0 for these graphs. All right, so we have an increasing graph. We would expect this to be positive. We have an increasing graph. We would expect our correlation coefficient to be positive. Again, our line is increasing. We would expect a correlation coefficient to be positive. And over here on the right-hand side, if you notice, this is kind of a loose but a downward trend. So we would expect this correlation coefficient to be negative. Now, we're not necessarily saying whether it's strong or weak or moderate at this point, but we are just assessing positive, negative, or 0. All right, so moving on. Example 2. Given the R value, the correlation coefficient, describe it as positive, negative, or none, strong, moderate, or weak. So for this first one, we'll do it together. R is equal to negative 0.85. This would indicate that we have a, based off of my scale up here at the top, this would indicate that at negative 0.85, I have a strong negative, since I have a negative sign, linear relationship. All right, so pause the video and complete B, C, D, and E on your own. Okay, now check. Did you get those right? For an R value of 0.01, we would be located somewhere right here. That means we have a weak but positive relationship. For 0.52, we would be located somewhere right here in that scale. We've got a moderate but positive association. For an R value of negative 0.75, we're somewhere over here between negative 0.5 and negative 0.8. We would have a moderate but negative relationship. And for an R value of 0.92, we would be located somewhere up here, which indicates a strong and positive relationship. So remember, the purpose of our R value is not only to tell us the direction of the correlation, positive or negative, but also to kind of give us an indicator of how well the data fits around the line. The more accurate the line is, the higher and closer to 1 your correlation coefficient will be in either direction. The least accurate your line of best fit is, or the more variety your data has, the closer to 0 your correlation coefficient will be. So closer to 1 on either side, very strong linear relationship. Points are very close to the line of best fit, if not on the line of best fit. And closer to 0 means more scattered around, okay? 0 meaning no correlation at all. -1 is a perfect negative fit, all points directly in a line. +1 meaning a perfect positive fit, all points are directly in a straight line. Okay? Let's move to example 3. In Mr. Hill's Spanish class, he took a survey and asked the students how many hours they spent studying for the vocab quiz. He compared this to the number of questions each student missed on the quiz. X is the number of hours spent studying, and Y is the number of questions answered incorrectly. All right, plot all the points on the graph. So let's take a second to label our x-axis, hours studied. Oops. And our y-axis, number of incorrect answers. All right, so let's decide how to scale our y-axis and our x-axis. I'm going from 0 to, it looks like 9, and I think I have enough room for that. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's go ahead and number by ones down here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. On my y-axis, looks like I need to go somewhere between 1 and 21. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can go by ones on this axis too. So I'm going to pause the video, and what I would like for you to do right now is to finish labeling up your axis and plot all of these coordinates on your scatter plot. Alrighty, take a second to look over your graph and make sure it looks like mine. Then let's continue on to our next set of questions. Use 2 points to calculate a line of best fit. So we realize that these points are kind of going in a downward direction. We've got a couple oddball points here, here, and here, but for the majority, we're kind of lumped in the middle. So you can choose 2 points of your liking. Remember, it's always a good idea and an easy idea if we make your y-intercept one of them. Okay, so for this graph, these are the points that I decided to use for our line of best fit. Of course, we've discussed how anyone can pick different points that may be a little bit different from mine, and that's okay for the time being. There is only one true line of best fit, but we're just concerned with a line that models the data appropriately, and at this point, this one does. I've got 3 points on my line of best fit. It follows the trend and the direction of the data. I have about half the points above and about half the points below my line of best fit, so this is appropriate for us. So we're going to use 2 points to calculate this line of best fit. I'm going to use 2 points that happen to be a part of the data set and on the line of best fit, but we do know that you do not have to use points a part of the data set or points on the line. You can use any point on the graph if you think you have a perfect intersection. So I'm going to use this point right here, which is 215. And this other point right here, which is 5, 6. So use the 2 points to calculate our line of best fit. I've got the point 215 and 5, 6. First step of calculating a line of best fit is finding your slope. So I'm going to label my points x1, y1, and x2, y2. And I'm going to find the slope of my line. Remember, y2 is 6 minus y1 is 15 over x2 is 5 minus x1 is 2. So 6 minus 15 would be -9 over 5 minus 2, which is 3. I would get -3 as my slope. And you want to make sure that your slope matches your correlation. I have a negative correlation here and a negative slope. So that works out perfectly. Now I need to use my point slope formula. And one point of my choice to plug into this equation and solve down for an equation in slope-intercept form, okay? So I'm going to go ahead and choose this first point right here to write that equation. So let's do that. Y minus y1, which is 15, equals m, which is -3, times x minus x1, which is 2. I can distribute my -3 inside. I get y minus 15 equals -3x plus 6. And if I add 15 to both sides, I get y equals -3x plus 21. So here's my equation of my line of best fit. And if you notice, my y-intercept is 21 and my graph does cross over here at 21. So you did a really good, nice, accurate job of representing our line. What does the slope and y-intercept represent in this scenario? All right, so let's start off with that slope. Your slope is -3 over 1. And remember, this is your change in y over your change in x. So we want to say for every one change in x, this happens to y in context. So here we go. For every one additional hour studied, okay, for every 1 hour we study, the number of incorrect answers on a test, on the quiz, on the assessment will decrease by 3. So remember, we want those words in there. I have a -3 over a +1. So as I increase by +1 in the x direction, I'm going to decrease by 3 in the y direction. So for every 1 additional hour studied, for every 1 increase in x, there is a decrease in y of 3. Change in y over change in x is the context of our problem. All right, let's look at our y-intercept. Our y-intercept is 0, 21. And how we interpret this is when x is 0, what happens to y? So let's check this out. If you study 0 hours, so if x is 0, then you will miss 21 questions, or actually I'm going to rephrase this a little bit differently. You will have 21 incorrect answers. So if x is 0, what do you expect from y? If I study 0 hours, I don't really expect to do well on this quiz at all, this assessment at all. So in order to interpret your slope, change in y over change in x. For every 1 unit change in x, what happens to y? And for your y-intercept, this is when x is 0, what's going on with y? It's our starting point, and it is kind of our initial value depending on the context. X is 0, what is y? Alrighty, last couple questions. Based off your model, what would you expect your correlation coefficient to be or look like? Make a prediction and explain. Okay, So we definitely would expect our correlation coefficient to be positive, or to be negative. It cannot be positive because that line is not increasing. So the slope is negative. Our correlation coefficient should also be negative. What do you think about it being strong, moderate, or weak? I want you to go ahead and answer that question on your own and be ready to justify in class why you think so. This is something that we will go over together. Strong, moderate, or weak, and why? If you spent 4 hours studying, how many questions would you expect to miss based on the line of best fit? Okay, so 4 hours studying, that is x. If x equals 4, what does y equal? What are my number of correct answers? So we can go look over at our graph. If x equals 4, how many answers do I expect to miss? I can come look over here and use my graph to estimate, just like we did on our Classy Cats activity. So according to the graph, I would expect to miss 9 questions. Let's use the equation to check, okay? I'm spending 4 hours studying, x is 4. We're gonna plug in 4 for x and see how accurate my guess and check was with my graph. This is negative 12 plus 21. And sure enough, I get y equals 9. So according to our line, we estimate if you study 4 hours, you will get 9 incorrect questions. So there's 2 ways you can do this. You can always look at your graph, but this unit is big about showing your work. So you can estimate using your graph, but if you're wrong, there's no backup for you. So show your partial credit or your extra credit so that you can get show your extra credit, sorry. Show your work so you can get partial credit for your work. So we can see what your process is, see what you're thinking. All right, last question. The person with the best score got all of the questions correct, so we missed 0. Use the function to determine how many hours it was most likely that they spent studying. All right, so the number of questions missed is 0. So we've got that y equals 0. So what's x? You're going to plug in for y equals 0 and solve for x. So 0 equals negative 3x plus 21. I can subtract 21 from each side. Negative 21 equals negative 3x. And if I divide by negative 3, x equals 7. So, according to our model, someone who missed 0 questions studied for 7 hours. And our graph can actually verify that for us. So we can look over here and say, if I missed 0 questions, how many hours did I study? Right here, we're at approximately 7. And of course, there's a little bit of human error with drawing a line straight on an iPad with a ruler, all of that. That's why you want to make sure you use your equation too, so that you get all of your credit, you show all of your work. So what we learned today is that A correlation coefficient gives us even more insight as to how accurately data is being displayed by a line of best fit. And we learn to use another set of descriptors, which is strong, moderate, or weak, to describe the line that we are fitting to our data, in addition to positive, negative, or no correlation. We are going to finish up example 4 in class, so do not do this for homework. Save it. We're going to do it together the next time that we see each other. All right? Have a great day. Bye.